Hello, sir.
Yeah, hi, Janissa.
Hi, sir. So actually, I wanted to ask, is there any update regarding the placements?
The placement, Vijay is actually speaking with some companies.
Okay.
So if there is any news from the company side, he will let you know. Okay, he is
Okay.
actually taking care of the placement part.
Okay. Okay. Thank
Yeah,
you, sir.
okay.
So good evening, sir.
Yeah, good evening, Yuvraj.
Sir, STM32 G4 series okay தானே சார்?
சீரிஸ் நம்பர் சொல்லுங்க. G4.
91G. அதுவும் M4ல தான் சார் வருது அது.
M4
நேத்து
ஆர்கிடெக்சர் தானே?
ஆமா.
அப்பனா ஓகே தான்.
ஏன்னா ஆக்சுவலா இதுக்கு முன்னாடி நான் யூஸ் பண்ணிட்டு இருந்தேன். ஸோ அதனால
ஓகே.
அப்படியே கண்டினியூ பண்றேன்.
ஓகே. நியூக்ளியர் போர்டா? டிஸ்கவரி போர்டா?
நியூக்ளியர் போர்ட் சார்.
நியூக்ளியர் போர்டு. ஓகே.
சார் ஒரு ஒரு
ம்
சின்ன என்கொயரி.
ம்
பிசிபி டிசைனிங்க்கு ஏதாவது கோர்சஸ் ஆஃபர் பண்றீங்களா சார்?
பிசிபி டிசைன் இருக்கு ஆக்சுவலா.
இருக்குங்களா?
ஆமா.
இப்போ எந்த மாதிரி சார் இருக்கும்? மீன்ஸ் வெறும் சாஃப்ட்வேர் மட்டுமா இல்ல ஹார்ட்வேர் ரிலேட்டடாவும் இருக்குங்களா?
எக்ஸாக்டா தெரியல.
ஆ,
இது மாதிரி ரமணன் சார் எடுத்தார் இல்லையா பிக்.
ஆமா ஆமா. ம் ம்.
ரமணன் சார் தான் ஆக்சுவலி பிசிபி ஹேண்டில் பண்றாரு.
ஓகே ஓகே.
அவர்கிட்ட கேட்டு வேணா நான் டீட்டெயில்ஸ் சொல்றேன்.
சரி ஓகே சார்.
ம் ஓகே.
ஆ
Okay, I will start the class. Yeah. Okay, so yesterday we discussed about the theory part of sorry. Yeah, so theory part of the ARM architecture, okay, as well as the STM32 board. Okay, so today we are going to see the GPIOs of how to write a GPIO driver for the STM32. Okay, so that's what we are going to see today. So how many of you here have hardware with you out of 8 people? Can I just put in a chat box? Because if you don't have an hardware with you, then I'll teach in the workway also. Okay, Arvind, others, Yuvraj. Okay. Mm, Venkateshwar, you don't have. Okay. Mm, Okay. Bala, which board you are having? What is the series?
Sir, nuclear F44 6RE.
F446.
Yes.
Okay. Okay. Yeah. So no issues. I will teach in both the hardware as well as the workway. Okay, how to connect in workway and all these things. Right. So what we are going to do is we are going to first we need to know about the board which we are going to work on. Okay. So the board I'm currently having is the Nucleo F334. Okay. So I'm just typing Nucleo F334 R8 user manual and you'll get this something from the ST microcontroller. If you have a different version of the hardware, okay, put that number over here. I think Aravind is having the discovery board, right? So instead of Nucleo, just type this whatever the number you have. Okay, discovery board user manual. You will get a user manual for that. Okay, so this is what the user manual for my board. Okay, so this is actually user manual for all these boards like F030, 070, okay, 72, 91, 103, 401, 410, 446, okay, 334. So all these boards, the same user manual for all these series of boards. Okay. Now, so what we are going to refer from this manual is, okay, before that we need to download 3 different documents. Okay, first one is you need to download the data sheet for your board. Second one, you need to download the reference manual, and third one, user manual. Okay, you should have 3 documents. Once again, I'll tell. First one is the data sheet. Okay, user manual and reference manual. Okay, so 3 things you need to have for all the boards. Okay, so here this is what my F334 board. Okay, if I just scroll down, there are some configuration settings will be mentioned in this user manual document. Okay, so I need to use all these things. Okay, I'll just open this in the edge. Okay. Right. So I'm just directly going to scroll down. Yeah. So this is an hardware block diagram. Okay. So what we infer from this hardware block diagram is this is, I think, common for your discovery board and all the series board. Okay. If you have a nuclear board or a discovery board STM32 board, this hardware block diagram is common. Okay. I think in discovery board, you don't have this Arduino connector. I think so, right? Arvind, I'm not exactly sure. Do you have an Arduino connector over there in your board?
Let me check. Let me check.
Okay, okay. Right. So this is an block diagram. If you take your board, this nuclear board, okay, or I will show you the image of the nuclear board. Any nuclear board will have a cut like this. F334R8. You can see the image. Yeah, this one. This is not an entire image. Okay. If you take this image, you can see over here. Yeah. So there is a cut in this line. Okay. There is an one part top and bottom part. Okay. So this is actually your STM, I mean, whatever the nuclear board you are having. So this is what the nuclear board. I'm just going to paste it in the OneNote. Okay. I'll show you what it is. Okay. So this is what your nuclear board looks like. Whatever the series you have. Okay. This is how it looks. This top part. Okay. This is your ST-Link programmer. Okay. Or this is not actually an, this is your ST-Link debugger. Okay. This bottom part. This is what your programming part. Okay. Now, so what is this debugger and programmer means? There are two different controllers over here. This is one controller. You can see this is another controller. Okay. This nuclear board or STM32 board is having, there is something called as an onboard debugging. That means you can actually able to debug the code, whatever you are writing via USB port. Okay. Mostly what we will do is in our PIC microcontroller also, we'll be using something called as an JTAG. Okay. So this we'll be using for our programming or a debugging. That means there will be no debugging device installed in your PIC microcontroller. You have to externally connect it. So what this debugger will do is it will convert your .elf file or .obj file, whatever it is, into this programming part, your machine level language. Okay, so that is what this debugger will do. Now, if you don't have this debugger part, what you will do is you will connect an external JTAG programmer. From this programmer, you can able to program this microcontroller. This is what your STM32 is, this bottom part. Okay. So this is your STM32. In my case, it is STM32 F334. Okay. And in your case, it will be STM32 4446 someone is having a 408 or 401, okay, whatever the series you are having, this is what that microcontroller is, this black color one. Now, if you want to program this, you need something external debugger, right? So JTAG, instead of that, what is happening is here we will have an internal debugger here. Okay, you can connect an USB over here to your PC and you can directly download your program into this microcontroller. Okay, via this ST-Link debugger. So this top part is an ST-Link debugger. What will happen is in your industry, you won't find this top part. Okay, this will not be available because in order to save the space, they will just program it once and they will just cut it. That's why there is a dot mark over there. Okay, they will just cut this part and you just only need this bottom programming part alone for whatever the connections you have. Everything will be given in this programming part only, right? Okay, so they don't have this debugger. Only once you program, they will just remove it. Okay, and if you want, you can externally connect some pins to that to change the program or whatever it is. So that is what this cut mark over here. Okay, now this board is having two controller, as I already said. This top part is for your debugging, okay, and this one is for your programmer, right? Apart from this, the left side we have two different pins available in this board. Okay, so this pin on the right extreme end and the left extreme end, this pin, we call this as an ST morpho pin. Okay, and the pin which is next to that, this pin we call, it's not visible. Okay, this pin we call as an Arduino pin. This green color one, again this green color one, this is an Arduino connector. Okay, ST morpho connector.
This board doesn't have this Arduino.
This core board doesn't have this Arduino pin. Yeah, okay. Right. So what this Arduino connector will do is you can actually able to connect your Arduino directly on top of this STM. Okay, yeah, that means you can sandwich this Arduino on top of this one. Okay, the same pins will be available, like you will be having a digital pins on the right side and analog pins and this control pin, whatever it is available in your Arduino board, that is available over here. You can use this as an Arduino connector also. Okay, you can program with an Arduino IDE. Okay, I will show that in the workview. Okay, you can program this with an Arduino IDE, with an Arduino syntax and everything, and still you can able to use this STM as an Arduino programmer. That is possible with this pin. Okay, and similarly STMorpho, you can connect this STMorpho pins. Okay, so there will be 30 pins on the right side and 30 pins on the left side. So totally it will be 60 pins. Okay, so this is what the pin configuration of your nucleo board. Okay, so discovery board is having a different connection. So this is what this hardware block diagram is actually telling. So you can see over here we have an USB. Okay, and this is your ST-Link. Okay, that is the black color on the top one. Okay, that is your ST-Link, and this is your STM microcontroller. This particular pin, there will be input output pins, reset and everything. On the left hand side you will be having a STMorpho, and right hand side you will be having XTMorpho, and this is where Arduino, this is your Arduino. Okay, so this is what, and simple hardware block diagram, okay, of your STM nucleo board. So discovery board is having a different one. I'll show that. Okay, now this is the top layout of your board. Okay, so if you are working with any board, before start working in that hardware, know about that hardware. What are the pins are there? What are the connections? How to configure it? If there is any jumper pins available in the board, how to connect the jumper pins differently? Okay, all these things you need to check. Okay, so here there are multiple things over here. Okay, there are lots of information. I will tell you what it is. This board is having an 4 different LEDs. Okay, I think, yeah, 4 different LEDs. I think so. Okay. The first one is this one. Okay. This is your LD1. Okay. Which is available right next to your USB port. If you have an hardware with you, you can directly see it. On the right hand side, there will be something like a white color LED. Okay. A big LED. So it is a multicolor LED. Okay. So there will be 3 different colors: red, green, and orange. Orange is nothing but it is a red and green combination. Okay. So each color defines a certain operation. Okay. Red means, um, okay, just a minute. I'm getting a call. Yeah, sorry. So red means your board is powered up. Okay. There is no other connections or no other communication, whatever. No, nothing is happening. Your board is simply powered up. Okay. So powered on. That is what this red color. If you connect your board to this your PC, okay, this will start glowing in the red color. That means the power is actually supplying to this one. Okay, that is one thing. Green color means there is a communication happening between your device to the board. Okay, a successful communication is happening between your device to the board. Okay, that is what an green color indicates. So this green color will be blinking, either blinking or it will be standardly glowing. Orange color defines there is an error in the communication. Okay, if there is any error in the communication, this LED will start glowing in the orange color. So that is what this LD1 is defined. This LD1 is actually for the communication indication. Okay, that is what this LD1 is. The next thing is we have an LD2. Okay, so LD2 is available over here. This is what your LD2 is. Okay, and we have one more thing, that is your LD3, and we have in we have 4 different LEDs. Just a minute. LD2, LD3, LD1. Okay. So this LD2 is an user defined LED. That means it is a programmable LED. It's an inbuilt LED. You can actually able to program it. It is connected to PA5, that is port A, 5th pin. Okay. By default for all the nuclear boards, it is PA5 only. Okay. So it is an user defined LED. You can program it. For example, if you want to blink an LED for any indication inside the board, onboard LED, then you can use this PA5 to define this onboard LD2. Okay. And this LD3 is for, as I already said, the top part is for the debugging and the bottom part is for programming, right? So this red color LED, red color glowing, it indicates the power on for the debugging. That means top portion. Okay. This LD3 is glowing in the red color. Okay. That means it is powered for the programming part. If the power is coming from the programming part, this LD3 will start glowing. Okay. So whenever you connect the board, make sure this is glowing in the red color, this LD1, and this LD3 is glowing in the red color. Okay. So that means there is a power supply is connecting to both this debugging part as well as in programming part. Okay. So that is what this thing is. Okay. So apart from this, so we have an user defined LED, right? That is for the output port. Similarly, we have 2 push buttons. Okay. One push button is over here, this one. Okay. So this is an user defined LED. So, user defined push button. Okay, so this part, I think in your nuclear board, you'll be having a blue color push button and black color push button. Okay, blue color push button is for the user defined push button. I think it is connected to PC 13 something. Okay, I'm not sure. We will check this in the IDE itself. Okay, no issues with that. So this is connected to something port C. I know port C, but pin number, I'm not sure it is 3 or a 13, but we will check this. Okay, so this is something like an PC 13, let's assume. Okay, it is connected to PC 13, and this is your reset pin. Okay, this is your reset pin, black color one. Okay, and what are the things you need to know? Okay. Okay, everything else is it's an inbuilt one. You just need to know only this. We have an USB connected over here. Okay, then okay, this part I will explain it again when we comes to the jumper pins. Okay, this part, this is stealing part. Okay, there will be two jumper pins available over here. Okay, on total we'll be having a 4 pins. This is for enabling your ST-Link. That means enabling your debugging, onboard debugging. Okay, so enabling ST-Link. If you unplug this, then you can't able to program through the USB. Okay, that is disabled. This jumper pins will be available over here. Okay, if you unplug this jumper pin, then you can't able to program it via USB. Okay, so that is the thing. Then what else you need to know? Okay, so apart from that, yesterday itself we saw we have an crystal oscillator, external oscillator, right? This is your external oscillator X1. Okay, this is an high speed external oscillator, and we have an X2 over here. This is a low speed external oscillator. Okay, so there is actually a space for X3, but it is left blank. We don't have an high speed external oscillator for the programming part. Okay, we only have for the debugging, we have an high speed external oscillator, and here we have a low speed external oscillator X2, X1 and X2. Okay. So apart from that, okay, this is your STM microcontroller, as I already said. This is STM32, and this is your ST-Link. Okay, so this is what the board you need to know. So for the discovery board, this will looks different. Okay, you'll be having a different setup, different kind
Yeah, I
of
have
board.
seen.
Yeah, you'll be having. Okay, just refer what are the pins available, what is your user
Yes.
defined pin and all these things. Okay.
It does additionally have some sensors also.
Yeah, it is having an additional sensors. Okay, discovery board is something like an inbuilt board. Some of the discovery boards is having an analog input also. I mean analog in the sense I'm
Yeah.
saying the audio inputs.
Audio sensor
Yeah,
is
audio
there, yeah.
sensors out there. Okay,
Yeah,
some of the
yes.
discovery boards are there. It's having. Since we have a digital signal processing, okay, we can actually able to process the signals so that we can able to do that. Okay, so this is what a simple nuclear board. Okay, is it clear? Is there any doubt for anyone? This looks very clumsy, but I hope this is clear for you. Is there any doubt in this?
No, sir.
Okay. Okay, this is the back side of your board. Okay, so there is nothing much we can able to do with this. It is pre-soldered. So we'll just skip this one. These are the dimensions. Yeah. So this is what the jumper connections, as I already said. Okay. This jumper should be on if you want to use an onboard ST-Link. Okay, so this jumper should be enabled. This ST-Link jumper should be enabled. And similarly, we have some other power supply jumpers. Okay, you can actually able to use this in the two different modes. Okay, one is you can able to power on through this USB, whatever you are connecting with your PC. Okay, so that is one thing. And the next thing is you can actually able to use this with an external 5 voltage supply. Okay, so that pin is actually available over here. Just a minute. Yeah. So this is, you can see on next to your LD2, on top of that your LD2, you will be having a jumper pin. Okay, there will be two pins. I mean, there will be three pins. Only two jumper pins will be connected. Okay. So here, if you connect this with this two, okay, there will be three pins, right? If you connect a jumper pin with these two pins, that means you are supplying through USB. Okay, and if you connect it with these two pins, okay, then you are connecting with an external 5 voltage. Okay, that means you can able to connect from the direct power supply. Okay, if you have a converter with an 5 voltage, that is, if you have a mobile adapter, you can actually able to power it through this USB. Okay, without this PC connection, you can actually able to power with an external supply. Okay, so that is possible with this external 5 voltage. So you just have to connect these two jumper pins to mention that I'm connecting an external 5 voltage to this. Okay, so this is one of the important thing. So apart from that, you will be having something called as an IDD. Okay, this jumper pin has to be enabled. Okay, and I'll tell you what are the jumper pins you have. First jumper pin is this ST link. Okay, this one you should check whether it is connected. Okay, and similarly, this is one ground pin. This is one ground pin. Okay, so you'll be having and two different jumper pins over here, and then you will be having a jumper pin for the power supply, and then you will be having a jumper pin for IDD. Okay, so this is actually a power supply for this programming part. If you remove this, you will not get any power supply to this one. Okay, so make sure you are having this.
On SWC, SWD.
You are having SWD, serial wide
Here
data.
also SWD jumpers also.
Where it is actually?
In the ST link itself.
This one.
Yes. Yeah.
This
SWD.
is usually okay. I'll tell you what this SWD is. SWD means it is an external programmer. Okay, as like if you want to program it like your PIC microcontroller, you can remove this ST link. Okay, you can directly connect an external JTAG. These pins can be directly connected over here. Okay, so either you can program it with an external JTAG, or if you want to program it through an USB, then you need to connect this jumper pin. Okay, if you want to connect an external, then you just remove this jumper pin and then you can connect it, or you can program it with this one. Okay, so that is what this pin is for.
Okay.
Yeah. Okay, and there is one more thing over here. This is must. Okay, and similarly this is must, either one, either USB or external 5 volt, that is must, and this IDD, it is also must. These ground pins, you should have at least one ground pin. Okay, if it is not two, at least you should have one ground pin connected. Okay, if both the ground pins are not connected, then your board will not communicate with your PC. Okay, at least you will be having a two jumper pins anyhow. If you don't have one jumper pin, just connect it with at least one ground. Okay, so you should have at least one ground connected, ST link, power supply, and IDD. Okay, so these are the connections for your board. Okay, make sure you are having this thing, and also there's one more jumper pin that will be available for TX and RX. Okay, so for this one. Okay, so this TX and RX, for example, in your UART, if you want to transfer it within your board, that is, if your TX will be received back to your RX of your board, also your RX, okay, then you will just connect an jumper pin to this so that there will be an internal communication will happen within your board. Or if you want to communicate with another board, connect this TX to its RX and that TX to this RX. Okay, so that is possible. So that is this TX and RX. If you want an internal connection, we will see this with your UART example. Okay, that we will see in our class. Okay, there we will use this TXRX. We need to short it. Okay, so that we can able to transfer the data and we can receive the data inside the board itself. Right. So that is what this TX and RX is. So this is for the jumper connections. So apart from this jumper connection, do we have anything else? Okay, so these are the pin diagrams. So if you are using 446, I think it will be over here. Yeah, so I think it will be over here, this nuclear 446. Okay, and I'm actually using an 334 R8. Okay, so this is my pin diagram. Okay, so this pin color one, this is my Arduino connector, as like the same Arduino pins A0, A1, A2, A3, A4, D0 to D13. Okay, and D14, D15 for this one, and we'll be having this power supply like 3 voltage, 5 voltage, ground, everything. Whatever the Arduino board is having, the same pin is available for this STM. This blue color one, it is the ST Morpho. Okay, so the left side and right side will be having two different connections. This PA, PB, PC, PD is nothing but these are your ports. Okay, as like your PIC microcontroller, PC is on port C, 10th pin, port C, 12th pin, port A, second pin, port A, 5th pin, all these things. Okay, so we will program with this one. Okay, then apart from this, is there anything? Okay, so this much as information, at least you should know about your board before start writing your program. Okay, know your board, then you can able to start writing it. Okay, so I hope everyone has installed the STM32. Okay, has anyone facing any issues while installing? So my previous batch student, I know they have already installed it for the RTOS. So this batch student, this batch Arvind, Bala, Guru.
I have 1.18.
1.8. No issues with that.
Okay.
That is the latest one. I think I'll be having 1.16.
Okay, sir.
No issues with that. Okay. Is there anyone has not even installed your STM IDE? Yogesh, Venkatesh, Naveen, Yuvraj, Augustine.
Installation done, sir.
Done, right? Okay. Yeah, so I'll just open this STM Cube IDE. Yeah, so this one is like a directory of your workspace where your program has to be stored. Okay, we'll be creating multiple projects in this module. Okay, so where all these projects has to be stored, that is what this directory workspace. So what I'm going to do is I'm just going to click a browse. I will open desktop. Okay, I'm just going to create a new folder which says device driver. On, okay, I'll just put a device driver. Okay, I'm just going to use this location. So default location will be your documents folder, I think. Okay, if you want, you can directly use it this document folder, or if you want a specific place where you can easily go and search your programs, then mention that location over here and then click launch. Okay, so this is how your main page will looks like for your STM cube IDE. Okay, just close this information center. This is not needed for us. Right, so this is what your STM cube IDE is. Okay, the main page. So our program, we are going to write it over here. Okay, so first thing, just go to file, new. Okay, there is something called as an STM32 project. Okay, since we are going to write an STM32 project, file, new, STM32 project. Just click this and it will automatically download the package for your STM32. So just wait for a few seconds. Okay, so once it is downloaded, it will open up the board configuration page. Yeah. Okay, this is a board selector page. This is where you and I will be differ. Okay, the programming part and everything will be same. If you are having a different versions of the board, then you need to just select it over here. I'll tell you what are the things. First one is an MPU MCU selector, this tab. Second one is the board selector. Okay, this is what your board selector is. Third one is your example selector, and fourth one is your cross selector. Okay. we can actually able to use either an MCU MPU selector or board selector. Okay, both are same, but there is a slight variation. I will just tell you what this variation is. First, I'm just going to use an board selector. Okay, then I will select an MPU MCU and I will show you what changes it is. So for me, I'm using a Nucleo F334 R8T6 board. Okay, that is what my board name is. So I'm just going to type the same thing, Nucleo hyphen F334 R8. So once you start searching here, start typing here, okay, the suggestion will automatically come. Okay, just select that board. That board will be listed over here on the right hand side. You can see this is what my board is. So once I start clicking this board, that board manual will be opened. Okay, so this is what my board is. So if you are using a discovery board, I think, let's say if I'm using an STM32 F334, this is what my discovery board is. Okay, if I click this for the same 334, this is my discovery board. Okay, so either you can use a nuclear board or a discovery board, whatever is it, just type that in the board selector. That's it.
Sir, one doubt.
Yeah.
Yeah, so my board is showing some disk one. What is that, sir?
No issues. It's a discovery one board. That's it.
Okay.
Yeah. Just make sure it is having that same image and that name, the entire name is same.
Sure. Sure.
Yeah. Okay. So this you have to do this for each and every project. Okay. So if you're going to use the same board for this entire module, instead of typing it each and every time, there is something called as an that favorite icon over here, this star. Okay, once you click this star, it will be added to your favorite list. Okay, so next time, instead of searching it, once you click this show only favorites, there you can see these are my favorites listed board. Okay, I can directly select the board from here. So instead of searching it each and every time, you can add it to the favorite and you can click it, the star icon, and then you will get that board. Okay, so once you selected this board, click next and it will ask the project name. Okay, so I'm just going to give first, let's make this as an LED blink project. Okay, so that is an first project for every microcontroller. Okay, so I'm just giving a project name as an LED blink. Okay, leave everything as it is, just click finish. Okay, if it is asking, do you want to initialize all the peripherals, click yes. Okay, it will load the IOC. IOC is nothing but it is an input output configuration page. Okay, so this is one of the important page in your STM cube ID. Okay, I'll show you what it is. Okay, has everyone got this page? As I already said, you should log in to this STM ID. Okay, if you're not logged in, then you will not get this board configuration. Even if you get this board configuration, you can't able to generate the code without login.
I able to open it this page, but I
Okay.
don't know whether
No
I able.
issues. No issues. We will check this with the code generation part.
Okay.
Okay. Others, can you confirm whether you got this page or not?
For me, the mail does not have arrived. I registered for the login account, but the mail does not arrive.
Okay.
So
For activating your account.
yes,
Right?
sir.
Okay. Can you give some other mail ID if you have?
Okay,
Do you have any other mail IDs? Okay, I try with some other mail ID and then check. Okay. Yeah. So this is what your input and output configuration page. Okay. So this is one of the very important, I'll say the GUI. Okay, that is available in the STM cube IDE. Why? Because in our previous module, this PIC module, what we did is we just configured the each and every pin by code. Correct. So for example, if you are using an port B0 pin, you need to mention that port B0 pin as an output pin by giving something called as an trust B0 pin. You just have to make it as 0 to mention it as an input or an output, whatever it is. Okay. Now here it is pretty simple. Okay. For example, as I already said, your PA5 is your, okay. This page is like I have given the nuclear board, right? Okay, so this is my nuclear board configuration. This will be by default. What are the pins available in my nuclear board that will be automatically assigned over here. Okay, you can see in my nuclear board, I have this PA5 as an inbuilt LED. Okay, so that is actually marked as an LED and I have an USART for PA2 and PA3. Okay, that is by default available. And similarly, I have an external oscillator. I have a push button on PC13 and then I have this SWO, TCK, okay, TMS, all these things. By default, you will get all these pins. Okay, this is what an board selector is. If you select that particular board, all these pins by default will be configured for you. Okay, there is no need to configure it manually. But if you select an MPU or MCU selector, okay, that I will show in the, as a next example. If you select an MP or a MCU, then you will not get this predefined pin configuration. You will get a blank IO pin. Okay, you just have to configure each and everything manually. So that is the only difference between your MP MCU selector and board selector. Okay. So I'm just going to leave it as it is because I'm going to use this internal LED PFI. Okay, so that is already marked as
For discovery, it's showing 4 LEDs. It's
you'll
from
be having a four
PD12 to
LEDs.
PD12 to PD15.
Yeah. So Discovery board is actually having a 4 inbuilt LED.
Different colors.
Yeah, different colors. Okay.
Okay, sir.
Right. You can configure any one of that LED. Okay. Right. What we have yeah. So if you want to remove this, for example, I'm just going to connect my external LED to some other pins. I don't want this PFI LED. Okay. So just click that pin and you can click and reset state. Okay, that will be removed. For example, if I'm going to connect it to PB0, my LED, just click this PB0 and then mark it as an GPIO output. Okay, then it will be marked as an GPIO output over here. Pretty simple. Okay, so there is no need to give it as an output pin, input pin in the programming and all these things. Okay, you can directly assign it as an in the GUI itself. Okay, this is one thing for the pin out configuration. And for the clock configuration, just click this clock configuration tab on the top. This is what your clock configuration is. Okay, I'm just going to maximize this a little bit so that you can see. Yeah. So as I already said, we have two different clocks available in my Nucleo board, right? One is an low speed external clock. This is one. And the next one is an high speed external clock. This one. Okay. Now, so yesterday we saw in the theory, we have three different clocks. One is HSI, one is HSC, and one is PLL. Okay, HSI is an high speed internal, HSE is an high speed external, PLL is an phase lock loop that we can able to use it for the multiplication of your clock. Okay, since my input frequency is only 8 megahertz. Okay, but if I want to use it to something like an 64 megahertz, then I can actually able to use this PLL. Okay, for example, I want only an 8 megahertz. I don't want any PLL. Okay, what I will do is I'm just going to select this. I'll just zoom this one. Okay, here you can see there is an mux. Okay, I'll select it as an high speed external. Okay, and I'm just going to make this PLL as multiply of 2. Okay, so this PLL input will be go over here. If you directly want to use an high speed internal clock, just select this high speed internal clock over here. On that right top, you can see everything else will be changed to 8 megahertz. Okay, it is as simple as that. You can configure your clock frequency by using this one. Okay, so if you want to reset everything back, just click this reset and it will reset your clock configuration as such to this 64 kilohertz for everything. Sorry, 64 megahertz for all these things. Okay, if you want, you can change it by using an prescaler. Okay, as like PLL is a multiplier, right? Similarly, there is something called as a prescaler that we have already seen in our PIC microcontroller. Okay, prescaler is a divider. Okay, if this is your input frequency, right? If you don't want a 64 megahertz, let's say you want a 32 megahertz. Okay, just make it divide by 2. You will get a 32 megahertz frequency over here. Okay, then I'm just going to make this as a 1. You'll be getting 32 megahertz frequency for all the peripherals. Okay, to your bus core, your cortex system, your clock, your APB1, APB timer, APB2 peripheral. Okay, all these things will have a 32 megahertz frequency. Okay, if you want to reduce it further, you can just make it divided by 4. You'll be getting a 16. Okay, you'll make it 8. Okay, so this is how your PLL and prescaler will work. Okay, if it is marked something like this purple color. Okay, why this is marked as a purple color, right? Yesterday we saw that architecture diagram. Okay, in that APB1, the maximum clock frequency for the APB1 is 32 megahertz. Okay, but here I am assigning it to 64 megahertz, so that's why it's showing as an error. Okay, so if I leave it divided by 2, I'll be getting a 32 megahertz frequency for only this APB1. All other systems will be running at a 64 megahertz frequency. Okay, if you want, you can change it individually for each and every system for a different clock frequency also. Okay, you can see for my Cortex system, it is running in an 8 megahertz. Okay, and my APB bus will be running in the 64 megahertz, that is memory bus, and my APB1 peripheral will be running in 32, timer will be running in 64, and APB2 will peripheral will be running in 16, and timer will be running in 32. Okay, you can actually change the clock frequency for each and every single bus by simply assigning some values to this. Okay, that much easy this STM ID is. Okay, so this is what in clock configuration. I'm just going to leave it as it is. So everything else will be running at 64 megahertz except this APB1 peripheral. Okay, now pin configuration all done. Okay, I'm not going to change anything. Now there is and one more thing in this IDE, that is all these configurations. What will happen? Your STM IDE will generate the code for all this configuration internally. Okay, there is no need to write the code for all this configuration, the clock configuration you have set it, or the pin configuration, whether it is an input pin, output pin, USART, oscillators. Okay, there is no need to write a code for the configuration in this STM cube ID. It will automatically generate the code for your specific board. Okay, so once you did everything, either you can give control yes, save. Okay, it will ask, do you want to generate the code? Okay, if you give control yes after doing all the changes. Okay, or there is something called as an project. There is a generate code over here. Either you can use this project generate code, or you can simply click on control yes to generate the code. Okay, so once I click this generate code, it will ask, do you want to generate the code? Click yes, and then do you want to open the C perspective? Click yes. Okay, now what will happen? All these configurations will be generated as a code. Okay, so if you want to open this main.c, just this is your project. Okay, LED blink on the left side. You can see, open this LED blink, open this core, open this. Okay, in core you will be having in 3 different folders. One is include folder. All your .h file will be inside this include folder. Okay, then we have an src folder, that is a source code. Then we have a startup code. Open this src, that is source code. You will find an main.c. So this is where we are going to write our code. Okay, so double click this main.c, you will open this one. Okay, now I'm just going to maximize this. Okay, now you can see this main.c is having somewhere around 251 lines of code. Okay, none of this as written by me. Everything is in software generated code for all the configurations. Okay, for example, if you just scroll down, you can see this is for my UART handle. That is UART2. I have made that configuration, right? So this is for my UART handle. And if you,
so
yes, sir.
I open, I mean, generate code is showing some FPU is not initialized in code itself, but project is compiling for FPU. Please initial the FPU before
Okay.
use.
For the discovery board.
I not even connected to a board. I need to connect.
No. You have configured for the discovery board only, right?
Yes.
Okay, I'll just explain this one, then you can share your screen, then we will configure. Okay.
Okay, sir.
Yeah. Just a minute, I'll explain this one. Okay, so you can see over here, we have an GPIO initialization function. Then you have an UART initialization function. So if I go to this GPIO initialization function, you can see the pin 5 is configured to output mode. Okay, so there is no pull up or anything is given. Okay, all these things will be automatically generated by your STM itself. Okay, so this is for your button one, which is configured to port C. Okay, and similarly, if you want to go for the UART, this is what my USART is. Okay, USART, this is my baud rate, this is my word length, this is my stop bit, parity. Okay, whether I'm going to use it in a TX, RX mode, all these things will be configured by my STM itself. Okay, so it is very simple to write a code. The only thing is just directly go to this while of one and you'll be start writing a code over here. Okay, so configuration part will be done by your STM itself, and even this code part will be very easy. We call that as an HAL programming, HAL. Okay, that is an hardware abstraction layer. It is very simple to easy to write the code also. Okay, I will explain this in a moment after solving Arvind's issue. Okay, Arvind, can you just share the screen?
Yes, sir.
So far, is it clear? Is anyone having any doubts? If any of this part is unclear for you, or if you want me to repeat it, just let me know. I will repeat.
Yeah, it's visible.
Yeah. It's visible. It's visible. Okay.
Oh, yes, sir. So the main dot C
Actually, you need
showing
to.
this here.
Okay. Yeah. Can I just go to this IOC file?
So I have opened.
It's not yet visible for me. It's still showing the code main.c file. Yeah, now it is okay. 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 Can I just close this connectivity? Just click that connectivity on the left side. Left side. There is an arrow mark. Click. Just click it. No. The category is timer, connectivity, all these things. No, close this timer. Yeah, close this connectivity. Close this timer. Okay, go to clock configuration.
Yeah, here it is too. So it looks different actually.
Yeah, since you will be having and more clock frequency, that will be different for you. Okay, so here we have an PLL APP resolve clock. Okay, everything is fine. Okay, HSC. So this main PLL, we have 168 megahertz of clock frequency. Okay, this is fine. Go to pin configuration now. Okay, board LED. Okay, go to system core.
System view.
No, system core. On the left side, you have closed this connectivity and everything, right? In that first one is system core. Okay. Go to sys. Click it. Okay, you are given debug as a serial wire and everything is fine. Okay, no issues. In week everything watchdog timer is not needed. Okay. in the top, there is a search bar, right? Can you just type FPU? It's not showing anything.
Okay, sir. Then I'll try to get it from the Google.
No issues. Okay, close the system core. We will explore because I haven't worked with this discovery board before, so I don't know this configuration. Okay, timers connectivity, security, middleware is not needed for this. Okay, can you just
this
click?
parameter has no parameter to configuration.
No, that is for the debug serial wire. That is, yes, that is not. Okay,
So
just
should
go
we
to
connect it
project.
with the board?
No, not needed. Okay, okay, now click project, generate code. Click yes.
Okay. I think I have missed. Sorry. I think this is my project. This is
Okay. Just right click that one. Right click that. No, not that. The project which you don't want. Can you just right click that one? The project one. That is 0_LED underscore toggle. Right click, close project.
Close it.
Yeah. After
Close.
that, refresh your close project. Okay. Okay, that is
I think
fine.
something is opening.
Okay. The problem is your code is not actually generated. Okay. Because you didn't logged in. Okay, just click help. The last one. Help.
Which one, sir? Help.
Help, yeah. In that there is something called as user storage. Eclipse user storage. Open my account. No, on top. Little bit down after the cheat sheets and everything. Eclipse user storage.
Showing active tips and
No, the next to that.
Yeah. Okay. Open my account.
Open my account. This is for Eclipse. Okay. I think you will get an password in your mail ID, a temporary password.
Yeah.
Okay, no issues. Can you just go to STM ID?
Yes,
Click help. Again, help.
Help. Sorry. Okay. Yeah, help.
Okay. Install new software.
Install new software.
Yeah. So this one is not okay. Just close this. Just a minute. Is there anything like check for target board something in your help? Go to, yeah, connection to my ST. That one. Connection to my ST. Enter my ST account information. You need to give an email address and password.
I forget.
Okay.
Okay, sir. I'll do
Okay.
this.
Yeah. Just logged in. Then you generate the code. It will open. Okay.
Sure.
Yeah.
Yeah.
Can you stop share the screen? I'll share it. Yes, fine. Okay. So this is what your generated code is. Okay. Now what we are going to do is we are going to write our program. Okay. Now in this generated code, you might have seen something multiple comment lines. Okay. There is something called as an user begin, include, user begin end, and all these things. Okay. Now what is meant by this is you can write your code anywhere. Okay. But the thing is, let's say I'm just declaring inside this main function, I'm just declaring int something like a equal to 10. Okay. I have written this line at line number 69. Okay. I have saved this file also, but let's say if I made any changes in my board configuration after written the code, if I generate the code, now what will happen is the code will generate for my IOC, right? Okay, during that time, you can see inside this main, the code, whatever I have written, that will be deleted. Because since this main.c is generated by your IDE, whatever you have written outside this specified area, okay, that will be considered as an additional line of code and it will be automatically deleted by your STM. Okay, so in order to avoid that, you should write your code inside this user code begin and before that user code end. Okay, so if I give something like an int a equal to 10 over here, okay, and something like an int x equal to something like an 45. Okay, now if I go over here and generate the code, okay, now you can see the code will be generated, but whatever the code I have written, this user code, that will not be deleted. Okay, so this is what an user code begin and user code end is. So there will be multiple user code begin and end. So this is the first user code begin and you have an second user code begin and end over here. Then you have third user code begin and end, and you'll be having a fourth user code begin and end will be over here. Okay. So these four places you can actually write your code wherever you want. Okay. And similarly, there are some specific areas that is given. So this is for your user defined include file. For example, if you want put something like an hash include stdio.h. Okay, so your include files will be given, should be given inside this one, and this is your private define, your private type def, your private macros, user defined macros. This is user defined variables. Okay, and this is your function prototype. If you're using any other functions inside your code, that function has to be declared over here. Okay, so something like that has to be given, okay, inside this user code, and we will explore this in our next examples. Okay, so this is where my main function starts at line number 66. Now what I'm going to do, I'm just going to first turn on my LED. Okay, not even blinking, I'm just going to turn on my LED. Okay, so for that, even in your pick program, what you will do, you will write everything inside a infinite loop, right? That is okay. Here inside this main, we'll be having an while of one at line number 98. Inside this, you can see user code begin over here. I'm just going to give an enter. Okay. Now I'm going to write my code. So for turning on my LED, and
Almost
I
done
know
with
my,
that.
what happened, Arvind? Okay. So I already know my LED is actually connected to PFI. You can see over here. Okay, this is where my LED is connected to. I'm just going to turn on my LED. Okay, so in your PIC program, since it is in bare metal, you will configure everything through the registers, right? But here we have something called as an APIs. Okay, APIs are application peripheral interface. Hmm. Okay, so all your register related things will be given inside a function, and that function you can able to call it anywhere. Okay, this function name is called as an API. Okay, inside this function you will have all these register informations. So in our bare metal programming we will be writing these registers, right? Okay, so that's what we have seen in the previous PIC module. Now instead of that bare metal, what we will do, we will just directly call this API. Okay, simply by assigning some values to this, some argument to this function, and this registers will be automatically assigned by your STM itself. Okay, that is what called as an API. And here we are going to use something called as an HAL API, HAL. Okay, which is nothing but hardware abstraction layer. Okay, so here we are going to use an HAL APIs. So HAL APIs are very simple. Just type HAL underscore. Okay, so till now what we are saying is this STM is actually made your programming very simple. Okay, we just configure everything in the GUI and it is automatically generated the code for you. Okay, and this GUI configuration is also very simple, like you just have to click it, make it as an input or an output, whatever it is. Okay, and even you don't have to remember this APIs. Okay, that much simple this STM cube is. Just type al underscore and give control space. Okay, it will just show all the APIs that are related to HAL. Okay, you just no need to remember all these APIs and everything. Just type al underscore and you will find all the suggestions for your APIs. Okay, here we are going to use in GPIO, right? Okay, so I'm just going to type al underscore. Okay, GPIO. Okay, once I type GPIO, you can see all my GPIO HAL related functions are over here. Okay, now I'm going to write the pin because it is an output pin, right? My LED is an output pin. Okay, so I'm just going to, you can see over here, there is a write pin over here. We can just double click it. It will automatically fill everything. Okay, the only thing is just need to change this parameter. That's it. You just don't have to write this entire API and all. Okay, so it is asking three parameters. One is which port, which pin, and what is the state of that pin. Okay, so first thing is I'm going to use an port A because my LED is connected to PA5, right? Okay, so this is my port A. Pin is, okay, just delete this because this pin has to be capital. Pin underscore 5. Okay, I'm going to use a fifth pin, PA5, right? So port A, fifth pin, and then pin status is set. Okay, I'm just going to turn on this one. So I'm going to turn on my LED at PA5. Okay, so that's it. A single line of code. This entire 250 lines of codes will be generated by your STM. You just have to write only one single line for turning on this LED. That's it. That much simple this AL STM is. Okay. So once you have done this, just click this build, this hammer icon over here, right? This is for the build, or you can just go to this project and build all. Okay. This is another step, or right click your project on the left side, whatever this project name, right click it. There is something called as a build project. Okay, either method you can use, whichever is feasible for you. Okay, so just right click, build, sorry, right click, build project. Now my project will be builded. Now you can see, so there is 0 errors and warning, the build is finished. Okay, so now still now we have written only this code, right? We haven't done anything else. Now I'm just going to connect my hardware to this PC. Okay, so just a minute, I'll connect this hardware. Okay, so my hardware is connected. Okay, I connected my hardware. Now what I'm going to do, I'm just going to right click this project. There is something called as an debug as. Okay, so debug as STM32C++ application. Once you connected your hardware, you just have to right click, debug as STM32C++ application. Okay, so it will just open an debug configuration. There is no need to change anything. Just click OK. This is your programming page, right? We are going to switch to the debugging page. Since we have an inbuilt debugger available inside this board, okay, we are okay to do with this. Okay, so it is asking, do you want to switch to the debug perspective? Click switch. Now this programming window will be switched to the debugging window. So this is what my debugging window is. Okay, you can see over here the download is completed. Okay, at the address of this ST link and all these things. Okay, and some of you, once you click this debug as, it will ask you to upgrade the firmware. Okay, just click upgrade. That's it. Because if you're using it for the first time, you just need to upgrade the firmware of your STM board. Okay, if it is asking, just click that one. Okay, so once it is done, we are actually inside this debugging, but still my program is not running. Okay, if I want to run my program, here under this run, there is something called as this resume icon. That's a play button. Okay, this icon. There are multiple icons. First one is terminate and relaunch. Second one is run. Third one is suspend. Fourth one is terminate. Okay, so I'm just going to click in resume. Once I click resume, my LED will start glowing. Okay, it is actually start glowing, but you can't able to see it. Just a minute. Teams. Okay. So as I already said, my LD2 is my inbuilt LED, right? Okay. Just a minute. Okay. This camera. Okay. You can see this is my inbuilt LED. Okay. So as I already said, this LED is blinking with the red and green, right? That means there is a communication happening between my PC to the board. Okay. And you can see over here, this is my LED that is actually glowing, starts glowing, this LD2. Okay. So this one. Now what I'm going to do, I'm just going to start blinking my LED. Okay. So I just have to come out from this debugging mode, right? So for that, click this terminate icon. There is a stop. Sorry, there is a stop icon over here. Just click this. It will terminate this debugging session and it will again come back to the programming part. Okay. So this is for my LED turn on, right? Similarly, I'll just copy this and I will paste it. Instead of set, if I give a reset, it will turn off my LED. That's it. Very simple. Okay. So turn on my LED, turn off my LED. That's it. Okay. Now if you want to blink, I mean, see it visually, I just need to give some delay, right? Okay. Here the delay also HAL delay only. HAL, again give control space, type delay, you will get this HAL delay. Okay. You can give this in the milliseconds. So I'm just giving in 1000 milliseconds. That means I'm generating 1 second delay. Okay. And similarly, I'm just going to copy this and paste it after the off 1 second delay. Okay. So I'll click this build. I'm checking there is a 0 errors and warning. Okay. Once that is done, I'm just going to right click this, debug as STM. The last, do you want to switch? Switch. Okay. So once I didn't run the program, okay, I'll just show the video. Okay. You can see this LED is off now. Okay, this inbuilt LED. Once I click this resume button over here, you can see if I click this resume, my LED will start glow for 1 second on, 1 second off. Okay, this inbuilt LED PFI. Okay, so for this LED blinking in our pick program, we'll be writing some, many lines of codes right here. Just 4 lines of code is enough for making this LED blink and all these things. Okay, with this AL API, it is very simple to use this device driver for this STM. Okay, since we are using STM board and STM IDE, okay, the code generation part will be taken care by your STM itself. There is no need to worry about that. Okay, so that is what the thing. Okay, clear? So this is for those who are using the hardware, and for others, those who don't have the hardware, okay, just go to this workvi.com. Okay, open this STM32. There are some pre-built projects available, but we'll be starting from the scratch. Okay, just select this ST Nucleo C03166. This is what the board is. Okay, now the problem is the code which I have generated is for STM32F334. Okay, the board I am having over here is C031C6. Okay, if I copy and paste this code, it will not work. Okay, because both the configurations are different. The clock pulse is different, pin configuration, everything is different. Okay, so now what I need to do, I just need to start creating a new project for this particular board. Okay, so those who don't have an hardware, so this is actually for you people. I'll do this only once today. Okay, so from tomorrow, if I do this for the hardware, the same thing you just have to do it for the workview simulator. Okay, so I just want you people to do on your own. If there is anything, just let me know. Same thing, file new STM32. The only thing that is going to be vary is the board selection. Okay, so click board selector. My board name is Nucleo C031C6, right? So I'm just going to type Nucleo C031C6, the first one. So I'm just going to select it. You can see this is what my Nucleo C031. Click next. It will ask the same LED underscore blink underscore simulator. I'm just typing it. So it will again load this IOC file. Okay, it is asking the user is connected to user LED is connected to LD4 user button, which will come. I'm just clicking OK. It will give the graphical user interface for me. Okay, so this is for my board. Okay, you can see this PFI is my inbuilt LED. Okay, then I have this PC13 is my push button. Everything is configured as it is. If you go to the clock configuration, so the maximum clock frequency this board can sustain is in 48 megahertz. That is actually given over there. Okay, so everything is same. Just Control S. I'm just going to generate the code. Okay, or I'll just directly go to this project and generate the code for this. Click yes. So this is my code generation. Okay, now in this code generation, again the same while of one. Okay, here I'm just going to write the same al underscore gpio underscore write pin. Okay, in this it is gpio a. I think the same pfi is connected over here. Okay, pfi. Okay, so a, this one is pin 5. So this is for set. Okay, or I'm just going to copy this and I'm going to paste it because it is the same code. Okay, for all the boards. Okay, save. I'm not going to build it because there is no need to build this one with the thing is right. So I'm just going to save this one. That's it. Now inside this simulation, I'm just going to give some connections to that. Okay, I'm having this LD3, sorry, LD4, that is my user defined LED. Okay, which is present over here. You can see this LD4. Okay, now I'm just going to blink that LED. That's what I'm going to do. For that, this is my sketch.ino. I don't need this sketch.ino. I need two files. One is this main.c file. Okay, and also this main.c file is actually including main.h. Okay, so I just need two files, main.c and main.h. Okay, now I need to manually create this main.c and main.h file. So just click this arrow mark over here, click delete. It will delete your sketch.ino. Okay, I don't need that one. So click new file. This is my main.c. Click create. Okay, and similarly again click this arrow mark, new main.h, create. Okay, so now I have two files, main.c and main.h. This program I'm just going to copy this main.c and I will paste it here. Okay, this is my main.c file. And similarly for main.h, I'll directly go to this main.h. Okay, hold your control button and click this, it will open main.h. Okay, that is one way. Or on the left side, inside this core, there is an inc folder, right? There you will have this main.c. Okay, so just double click, you will find the main.c, copy and paste it. Okay, so this is what your main.c and main.h file. Okay, now I need to connect this PFI to an LED, right? So I'm just going to do the connection with this one. Let's check where this PFI is. So this is my PFI. Okay, so now I'm just going to take an LED and or since it is an inbuilt LED, we will just leave it as it is, no issues. Okay, so once I click start the simulation, let's check if there is any error. Okay, there is an error, no such file for this nucleo.h. Okay, I'll just remove this one. This nucleo.h header file is not available. Okay, so start the simulation. Mm, Oh, okay. So you won't have this thing. This is only available for the HAL, right? Okay, we'll do one thing. Library manage. Just a minute. STM32C. This STM32C0. Okay, this push button and the communication protocol, all these things, it's showing some error since it doesn't have this inbuilt API. Okay, I'm just going to remove everything. Or I'll just put this inside a comment. Let's run this. LED initialization, green LED green. Okay, those who are working in the hardware, have you got the output?
Have
And
one small doubt, sir.
yeah,
And while I mean after credentials are update, now it's working. Generate code is working for me.
okay.
But while of one is showing some MX USB host process function, should I remove that?
Where?
MX USB host process function is showing inside the while of one in main function.
Okay.
Should I remove that?
But it is working, right? Is it blinking?
To debug it.
Okay.
showing also showing no ST links detected.
No ST link detected means your board is not actually finding this debugger, this top part. Can you just check all your jumper pins? I think the discovery board is having an internal ST link. Just a minute.
Yes, sir, there are two block things are connected.
Okay. ST link for STM32 discovery board. Mm, 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 mm. Okay, it has an integrated ST debugger programmer, but make sure this specific ST link is connected. This one, two jumper pins. Okay. Others, I think, who else is having the board? Yuvraj,
Yes, sir. Done, sir.
done. You
Working.
got an output. Okay. Then others. Oh, okay. Is anyone else having a board? I think overall posted here. I think Bala. Yeah, Bala. What about you? Have you got an output?
Completed.
Completed.
Sir.
Okay. This STM, I don't know. This is not working. I'll just show one thing. Just a minute. This is for the main.h. Same thing. Okay. This is for PFI. If I start, you can see this inbuilt LED, this LD4, it will start blinking. Okay. Even if you
So
connect the
showing
same.
STM link update. Should I update it?
Yeah, you just have to upgrade it.
Okay.
Okay, so this is for the workpiece simulator. Okay, we just have to work with this somehow. Okay, I'll show the steps entirely from start to end. How to generate the code, how to copy and paste, and all these things. Because there will be some problem with this JSON file if I have created this one. We will check this one. Okay. This process I will explain tomorrow for those who don't have the board. Yeah. Arvind, can you
Sir, it's
just
asking sir
yeah.
switch
Can you just
switch
start
from
sharing your screen? I'll tell you the steps.
yeah. It's showing some switch.
Yeah, you just have to click switch because you are switching from the programming mode to debugging mode. Okay, so click switch. So now this debugging mode will open. Okay. Now below that navigate menu bar. Okay, there are multiple menus on the top right. File, edit,
Yes, sir.
source, refract, navigate, search. Not there, left side.
Left
Your
side,
menu bar. Okay.
Okay.
Yeah, below that
Navigate.
there is a resume button. Below that navigate. Don't click that. Don't click that. Yeah, below
This
that
one.
navigate, there are
Yeah,
multiple
yeah,
icons,
yes.
right? Yeah, click resume.
Yes. Yeah, it's some
Okay.
red color is blinking,
Ah.
but I have given red color. No? Yeah, P10 I have. PA15, 14 I have. PD14 I have given. So D port and 14th I have. Yeah, it's
PD14
blinking.
is a red LED.
Yeah, red I have.
Okay. So this is for a simple LED
This
blinking.
is only as MX USB host processes. Yeah, it's blinking.
Okay.
Sir.
Okay. Can you just hold your control button and click that function? Hold your control button and click that MSP host. Yeah, click it.
Yes, sir. It's open.
Okay. So it is actually for the USB host background task. Okay. Okay. Now open that 98th line. Similar way, just hold your button and click that USB H process 98th line. Okay, this is for checking whether your USB device is connected to your board or not. Okay, that is an internal process that will be keep on checking if your device is ready for communication. Okay, you can just leave that code as it is. If you want to see any of that function, you just open it by holding that control button and click that function. It will take you to the function definition.
Yeah,
okay.
it is showing here.
Yes.
Oh, okay.
Okay, so this is what an GPIO. In GPIO, we have seen only the LED blinking. Okay, still we have this push button that we will explore tomorrow. And also I will explain this step by step how to create a new project and copy and paste everything tomorrow for those who don't have this board. Okay. The only thing is just how
Should
to
we terminate this project? How to
which one?
terminate this? This
Yeah,
currently
there's a
blinking.
terminate button. Oh no, you can't. Once you start no downloaded that program, your program is keep on running inside the microcontroller, right?
Yeah, once
Until
I click in the
until you
power
power
supply,
off that, it will keep on running. Since you are given
How
is
is
a while of
reset loads?
result also your program will start running from the beginning.
Okay, got it.
That's
But
what
same program is in the chip, so it will run this
yes,
one.
it will run continuously. Since it is given while of 1, it will be continuously executing. Yes.
Got it. So should I remove directly, or here I can give any stop button?
No, you can remove directly. No issues.
Okay. Thank you.
Yes. Okay, so this is what in simple programming with your STM board. Okay, so tomorrow we'll see how to connect an external LED, how to program external LED, and also multiple LEDs with this one, and with this push button, how to give an input. Based on that input, how to turn on this LED, that we will see tomorrow, as well as this work with simulator that also we will explore tomorrow. Okay, and I will share yesterday's link as well as today's link. I will put these 2 videos in the OneDrive. Okay, and I'll share you the link in your group by tomorrow morning. Okay. Yeah. Is there any other doubts?
Sir?
Yes.
After this,
Yes,
are you available in call, sir? I want to call you.
Tomorrow afternoon I will have a class.
No, after this call, just want to
after
call.
this one. Oh,
yes.
yeah. Okay. You can call. Yes. Okay. Is there any other doubt?
For powering the STM board, we will use what type of cables, C type or some other specific cable?
It is actually the micro USB.
Micro.
Yeah, USB A to micro USB.
Oh, so we have to bots that also separately.
Yes, your nuclear board, you won't get an cable for that. Okay, this is, I'll just show you. Is my screen visible? No, right? Okay. Arvind, can you just stop sharing the screen? Thanks. So this is your USB A to micro USB. This one. Mm, is it micro or mini? No. This is for mini USB, I think. Yeah, this one. Okay. For my 334, it is a mini USB. Okay. I'm not sure about the other boards because the G series board, they are using the micro USBs, the same nuclear board. Okay. This one. This is for the micro USB for G series board. You're using G series, right? RF. Which series you're using?
Uh,
Okay, just check with your board. Okay, which type of connection it is. It will be mostly a mini USB or micro USB. These two only. Okay, so just check with that one.
okay, sir.
Okay, so this is your mini USB and this is your micro USB. Just make sure whether your connector is this much size or it has a this size. Okay, you can get that one. Okay, any other doubts?
Sir,
Yes, Aparna.
what is the difference between JTAG debugger and Seeger debugger, where it is used and how to use that, sir?
Sager debugger. Okay, JTAG debugger is like what to say. Okay, in Sager debugger, you can actually able to visualize it. Okay, Sager as a tool, it is like your oscilloscope. Okay, there we can able to visualize the output. Okay, that is in Sager. Where JTAG is only for the onboard debugging purposes. Okay, like in C program or even here, uh, is my screen visible? Yeah. Okay, so if I go to this debugging process, I'll just go to this debugging process. I can mark a breakpoint over anywhere. Okay, we have seen the PIC microcontroller, right? Okay, that PIC microcontroller is actually using a JTAG debugger. Okay.
Yes, sir. Yes, sir.
So what happens is this JTAG is actually making your processor stops and it will read the registers and memory and it will show the result for you. That is what a JTAG will do. Okay. It has 4 wires as like your PIC microcontroller we have connected the same thing. Whereas Seger, you can actually able to do that in the real time process. Okay.
Yes, yes, sir.
Yeah.
Thank you, sir.
Yes. Okay. Anything else?
Sir, and I have issue with the MPLab XID, sir.
Okay. What is the issue?
Before the last week, I had faced issue like that, and the hex code was not generated, sir, in the MPLab XID.
Okay. But the code is generated, right?
Yeah, when I click build from the source to C, main C, I created the file.
Okay.
After build project click means it was creating, but when I used to go and go in the Proteus and search for it, the hex file is not generated, sir.
Oh, in PIC microcontroller.
Proteus, yes, sir.
PIC microcontroller. Okay, in IDE, MPLAB IDE, this hex file is not generating, right?
Okay.
Mm,
Previously, it was generated. The last week,
okay.
the last 10.
Are you clicking from the project build, or are you clicking that hammer symbol?
From the hammer symbol, sir.
Okay. If you click an hammer symbol, you will get a .elf file. Okay, you won't get a .hex file. Okay, both are an output version only, but it will consider as an I don't know what the problem is with that icon, but if you click this hammer symbol, it will consider as an cross compiler, and it will generate .elf file instead of .hex file. Okay, go to project and then build it. It will generate the exe file. Okay, that is an issue.
The hammer, go to project.
Hammer symbol is for ELF. Okay, go to project and build it for the .hex file.
Okay, sir.
Yes. Just try it, and if you're not getting, just let me know. Okay.
Okay, sir.
Yeah. Okay, Gaston. Okay, is there anything? Any other doubts? Okay, then we'll see tomorrow. Thank you. Bye.
Okay, sir. Thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.